Evaluate the definite integral. So this says 0 to pi over 4 sine theta over cosine cubed theta d theta. So to evaluate a definite integral, you need to use the fundamental theorem of calculus. Find an antiderivative, plug in the two numbers. But to do the antiderivative of this function, I need a u substitution. And I'm going to pick u to be cosine theta, because that's sort of what the denominator has in it. The derivative of cosine is negative sine theta d theta. I'm going to solve for d theta. So it's du over negative sine theta. Okay, so I'm going to rewrite this guy. I'm going to put little dots here to remember that there are limits, but they're not in terms of u. So I'm going to leave them out because I don't quite know what they are yet. So I have sine theta over u to the third. Remember we found d theta, so that's du over negative sine theta. And those sine thetas go away. So we have the integral of negative u to the negative 3 du. So let's integrate that. Oops. So when we integrate that, we add 1 to the power. So negative 3 plus 1 is negative 2, and divide by the new power. And I'm going to put this little bar with those dots to remember. So I have 1/2 u to the negative 2. I started with thetas, so I want to end with thetas. So I'm going to put that cosine theta back in. So cosine theta to the negative 2. And now I can go back and use my bounds again, my limits of integration, 0 to pi over 4. Okay, so remember to evaluate this, you're going to plug in pi over 4, and you're going to subtract what you get when you plug in 0. So 1/2 cosine pi over 4 squared minus 1 to the negative 2 minus 1/2 cosine of 0 to the negative 2. 1/2 cosine of pi over 4 is square root 2 over 2 to the negative 2 minus cosine of 0 is 1 to the negative 2. Okay, so this gives me 1/2. This is like squaring, but I have to flip it over. The negative means flip over. So 4 over 2. You could also just put this number in your calculator, and you should see that you get 4 over 2 or 2. Minus 1/2. So this is 1 minus 1/2 gives me 1/2.